Hello students, now today we are going to discuss periodic and aperiodic signals. Already I told you in your previous class continuous time periodic signal. If the continuous time periodic signal, if the signal is periodic, that is your what? X of t equal to x of t plus capital T, where t is your capital T is your fundamental period. So in a discrete time signal, if the discrete time signal is periodic, if periodic versus aperiodic signal, as already I told you, suppose if in a continuous time periodic signal x of t equal to x of t plus capital T, where here t is the fundamental period. So every fundamental period the signal is repeated, so that we can say that the signal is periodic, otherwise the signal is aperiodic signal. Suppose if a more than one sinusoidal signal is also a periodic signal, suppose if it is consist of suppose x of t equal to suppose let sin omega 1 t plus sin omega 2 t. A sinusoidal signal is periodic with the period pi. So if omega 1 t plus omega 2 t, and this is the sum of the two sinusoidal signals, or you can say the multitone signals. In a multitone signal is periodic, we have to find the individually find out the fundamental period. This is the first periodic signal and this is the second signal. If it is a periodic and it is a periodic, there is no guarantee the sum of the two sinusoidal signal is periodic. How to identify the sum of the two sinusoidal signal is periodic or not? After finding the fundamental period T1 and T2, T1 is the fundamental period of this signal and T2 is the fundamental period of another signal, and find out the ratio of T1 by T2. If it is an integer, we can say that the sum of sinusoidal signals or multitone signal is periodic. And then after when you know the signal is periodic, then we have to find out their common period. And how to find out the common period? This is your letter T1 is the fundamental period of this signal and T2 is the fundamental period of the another signal, and find the LCM of T1 and T2, you will find out the common period, that is your T. So we can say this is your x1 of t and this is your let x2 of t, and x of t equal to x1 of t and x2 of t, sum of x1 of t and x2 of t. If x1 of t and x2 of t individual periodic, there is no guarantee the sum of the two periodic signals are periodic. So to confirm or to find out, to identify whether the signal is periodic or not, a multitone continuous time signal, first of all you have to find out the time period of first signal and time period of another signal, then find out the T1 by T2. If T1 by T2 is a rational, or if T1 by T2 is a rational number or ratio between the two integers, we can say that the signal is periodic. And to find the common period, if you will find out the LCM of T1 and T2, we will get that is your fundamental period. So that part already I told you in your previous class. Now today, in case of continuous time signal, so this is all about is your what? That is your continuous time signal. Suppose in a discrete time signal, as far as signal processing is concerned, we are more familiar with the discrete time signals. A discrete time signal is said to be periodic. A discrete time signal let x of n is periodic. A discrete time signal x of n is periodic if and only if the condition is what? X of n must be equal to x of n plus capital N. Here n is the common period. Already I told you, suppose a discrete time signal, let this is your n equal to 0, n equal to 1, n equal to 2, n equal to 3. This is your 1, 2 and 3. Amplitude is your 1, here 2, here 3 and this is your 4. Again this sequence is repeated. If the sequence is repeated, we can say that, so that is your 4, 5 and your 6 and 7. We can say that the sequence is repeated every after 4 unit samples. So that's why you can say that the fundamental period n equal to what? That is your 4. So if the 4 samples After 4 samples again it will come 1, 2, 3, 4. Again after 4 samples then it will come 1, 2, 3, 4 like this. These signals is repeated again and again at every 4 samples, after 4 samples. So we can say that the discrete time signal x of n is periodic. So if a discrete time signal is periodic, the condition is what? X of n equal to x of n plus capital N. Any sinusoidal signal, suppose a sinusoidal signal is periodic, let x of n equal to a sin omega 0 n plus theta. A discrete time sinusoidal signal is periodic with the fundamental period, that is your 2 pi or pi. Here omega 0 n plus theta, here a is the amplitude, omega is your frequency and theta is your phase shift. So x of n equal to a sin omega 0 n plus theta. A is the amplitude of the sinusoidal signal, discrete time signals, omega 0 is your frequency and theta is your phase shift. Suppose x of n plus capital N. X of n plus n is what? In place of n, I will put n plus n. So that's why this equation becomes what? A sin, that is your omega 0. In place of n, we can write n plus capital N, then plus theta. Okay. So this is nothing but what? A sin omega 0 n, a sin omega 0 n plus omega 0 capital N and plus theta. So let this is your equation number 1 and let this is your equation number 2. So for x of n, this equation, if this is periodic, means what? That is your omega 0 n must be what? In case of continuous time signal, omega 0 is nothing but, if you will memorize the continuous time signal, a sinusoidal signal is periodic with the period pi. So omega 0 is nothing but is your 2 pi. So here omega 0 n, so omega 0 n, if this condition will satisfy, equation 1 are equal to equation 2, so omega 0 n value is what? Omega 0 n is nothing but integer multiple of 2 pi. Remember, as far as discrete time signal is concerned, if it is a continuous time signal, we can direct write omega 0 capital T in place of capital N. In case of continuous time signal, we can write omega 0 t. So omega 0 t equal to 2 pi. Then after that, we will find out what is the value of t. T is nothing but is your what? 2 pi by omega naught in case of continuous time signal. In case of discrete time signal, omega 0 n is nothing but integer multiple of 2 pi. 2 pi into m, where m is an integer, where m is an integer. Remember, as far as continuous time signal is concerned, the omega 0 t equal to 2 pi, then we will calculate t equal to 2 pi by omega naught in case of continuous time signal. In case of discrete time signal, here value n is the discrete values, that is your n equal to 0, 1, 2, 3, 4, etc. n equal to 0, 1, 2, 3 or minus 1, minus 2, minus 3. So n is an integer. So that's why omega 0 n must be equal to integer multiple of 2 pi into m. Then n value is how much? From this equation, we will calculate value of n, where n is nothing but is your fundamental period of discrete time signal. So n equal to 2 pi into m by omega naught. 2 pi by m by omega naught. It is very, very important. This condition is for what? To find the fundamental period of a discrete time signal, n equal to 2 pi into m by omega naught. Another important thing is what? To compute n, the minimum value of m in which n is an integer, that is called we have to choose the smallest or minimum value of m. To compute m, to compute n, the value of m is smallest, so that n equal to 2 pi into m by omega naught is an integer. It is most important. This concept you must keep in your mind when you are going to calculate the fundamental period of a discrete time signal. So n equal to 2 pi into m by omega naught. The value of m, the least value of m, you have to select the least value of m so that n equal to 2 pi into m by omega naught must be an integer. For example, I will give you an example. Suppose omega naught value, omega 0, if omega naught equal to 6 pi by 13. Omega 0 equal to 6 pi by 13. So how will you compute the value of n? Suppose a continuous time, discrete time signal is given, and for that signal you confirm that omega 0 equal to 6 pi by 13. So how will you calculate the fundamental period n? So how will you calculate the fundamental period n? The n equal to, our formula n equal to how much? N equal to 2 pi into m by omega naught. Omega naught value is nothing but what? 6 pi by 13. And this will be equal to what? 2 pi into m into 13 divided by 6 pi. Okay, this pi cancel. Tell me, this is your 13 into 2, 13 into 2, 26. So what is the value of m? I will choose. What is the value of m? I will choose. So that the whole must be an integer. So m value, if value choose 1, if m equal to 1, the value is what? 2 into 1. That means this is not will be an integer. If m I will put 3, if m 2, if you will put m equal to 2, 2 to the 4, this is not be an integer. Then I will choose m equal to 3. If I will choose m equal to 3, 3 into 2 6, and 6 will be cancelled. The value of n is how much? 13. So in this case, so the value of m is how much? The value of m equal to 3. If m equal to 3, n must be equal to how much? N equal to how much? That is your 2 into 3 into 13 divided by 6. That will be cancelled out, and the value of n equal to 13. Okay, it is very important when you are going to calculate, or when you are going to evaluate the fundamental period or common period of a discrete time signals. First of all, how to calculate capital N. If you know what is the fundamental frequency, omega 0 value, to compute n equal to 2 pi into m by omega naught, and the value of m, you have to choose the value of m. We have to choose the value of m, the minimum value of m, for which n equal to 2 pi into m by omega naught is an integer. That's then the value of, then you will calculate the fundamental period or common period. So in this way you can calculate the fundamental period or common period of a discrete time signal, and if the signal is periodic, then you will calculate the fundamental period. So now I will give you some examples. It will be better for you, for your understanding. And this is examples. Determine whether or not each of the following signal is periodic or not. If periodic, specify its fundamental period. So here, first example is your what? X of n equal to that is your e to the power j 6 pi n. It is clearly mentioned that this pi is multiplied, e to the power j theta equal to cos theta plus j sin theta, the cos 6 pi n plus sin 6 pi n. So that is your, since it is a multiple of pi, we can say that the signal is periodic. Since it is multiple of pi, the signal it is multiple of pi, the signal is periodic. Since it is multiple of pi the signal is periodic. The signal is periodic. Okay, and then we will calculate the common period, that is your n. So clearly mentioned that e to the power j omega 0 n. The omega 0 value is how much here? Omega 0 value is your 6 pi. Here omega 0 equal to 6 pi. Omega 0 equal to 6 pi. If omega 0 is 6 pi, then we will calculate the common period. So n value is how much? N equal to, you know, 2 pi into m by omega naught. 2 pi into m by omega naught. The minimum value of m for which n is an integer. The minimum value of m, and here omega naught value is how much? That is your 2 pi into m divided by omega naught value is your 6 pi. 6 pi. Here pi cancel. Clearly, what is the value of m here? I will multiply 2 so that whole thing will be an integer. Clearly, if I will choose 1, that is your 2 by 6, it is not an integer. If m equal to 2, 2 to 4, 4 by 6 is not an integer. If m equal to 3, 3 to the 6, 6 will be cancelled out and the value of n will be 1. Here, the minimum value of m here satisfy what? M equal to 3. So, for m equal to 3, then n will be how much? That you will be 2 into 3 divided by 6 and the value will be 1. Now clearly here x of n e to the power j 6 pi n, and here the signal is periodic because the fundamental frequency is multiple of pi, and then to find the common period the value n equal to how much? N equal to 1. Okay. So next example, II. X of n equal to e to the power j 3 by pi n plus 1 by 2. In this example, here pi, omega 0, it is divided by pi, it is not multiple of pi. If a to the power j omega theta or j omega 0 n, clearly pi is a denominator. So pi is not multiple with fundamental frequency. So that's why the signal is not periodic. If the signal is not periodic, it is a what? An aperiodic signal. So since in this example, it is the fundamental frequency is not multiple with pi. Fundamental frequency is not multiple of pi. Rather, it is divided by pi. The signal is not periodic. It is an aperiodic signal. Okay. Then another one. Number 2 is your aperiodic signal. Aperiodic. Then third. X of n equal to cos 2 pi by 3n. Cos 2 pi by 3n is what? The fundamental frequency is multiple of pi. If the fundamental frequency is multiple of pi, the signal is periodic. The signal is periodic. Fundamental frequency omega 0 is multiple of pi. Multiple of omega 0 is nothing but multiple of pi. Signal is periodic. The signal is periodic. If the signal is periodic, find the common period or fundamental period. And formula is what? N equal to 2 pi into m by omega naught, which equal to 2 pi. We have to choose m. Omega naught value is what? That is omega naught equal to 2 pi by 3. Here omega naught equal to that is your 2 pi by 3. Omega naught equal to 2 pi by 3. So 2 pi m by what? 2 pi by 3. And the 3 comes to the numerator. That is your 2 pi into 3 into m divided by 2 pi. 2 pi will be cancelled out. What is the value of m? So that if any value, minimum value of m cannot be 0. So m is 1. For m equal to 1, n equal to how much? N equal to 3. So minimum value of m here, it is clearly minimum value of m will be 1. If m equal to 1, for m equal to 1, so n is nothing but what? That is your 3. And in this example, the fundamental period or common period is 3. Then comes to next example. Number 4 is what? It is most important examples. X of n equal to 2 sinusoidal signals cos pi by 3n plus cos 3 pi by 4n. Here x of n equal to is nothing but x1 of n plus x2 of n. One thing already I told you, if sum of the two sinusoidal signals or two signals sum of two signals. If individual signals are periodic, there is no guarantee the sum of their periodic signals is periodic. If x1 of n is periodic and x2 of n is periodic, and there is no guarantee the x of n is a periodic signal. To check whether the signal is periodic or not, first of all we have to calculate, we have to evaluate the common period x1 of n, that is let n1, and common period of x2 of n, that is n2. Then calculate n1 by n2. If n1 by n2 is a rational numbers, is a rationals, then we can say that the sum of sinusoid or multitone signal, multitone discrete time signal is periodic. And then you can calculate the common period. How to find out the common period? After getting n1 on n2, LCM of n1 on n2, it is your common period. In this example, first case, x1 of n is how much here? x1 of n equal to cos pi by 3n. Okay, omega 0 value is how much here? Omega 0 here, omega 0 equal to, that is your here omega 0, this value is your omega 0. Omega 0 value is your pi by 3. Omega 0 is your pi by 3. To compute n1, what is our formula? 2 pi into m by omega naught. 2 pi into m by omega naught. That is your 2 pi. We have to select m, value of m by omega naught pi by 3. Pi by 3 means 3 come to the numerator. The pi will be cancelled out. What is the value of m? M is nothing but here least value of m means m equal to 1. So for m equal to 1, n1 equal to 6. So that is our first fundamental period of the x1 of n equal to n1 equal to 6. Next, that is your n2. In case of second periodic signal, x2 of n, omega 0 value is how much here? Omega 0 value, and second x2 of n is how much? x2 of n equal to, that is your cos 3 pi by 4, 3 pi by 4n. So that is your our formula to compute n. So n2 equal to, here omega naught equal to how much? Omega naught equal to, that is your 3 pi by 4. Omega naught equal to 3 pi by 4. n2 equal to 2 pi into m by omega naught, which equal to 2 pi into m by omega naught is your 3 pi by 4. 3 pi by 4 is coming to the numerator. Here pi will be cancelled out. What is my value of m? If m equal to 1 means 2 into 1 2, 4 to the 8 by 3 is not an integer. M equal to 2 to the 4 into 4 16 by 3 is not an integer. If m equal to 3 to the 6, 3, if m equal to 3, then this will be cancelled out. For m equal to 3, the value of n2 equal to, that is your 3, that is your m equal to 3, m equal to 3, that is your 2 into 3 into 4 by 3, 3 cancel. So n2 equal to 8. So first n1 equal to 6 and here n2 equal to 8. n2 equal to 8. If n2 equal to 8, then calculate n1 by n2. n1 by n2. So n1 by n2 is how much? n1 by n2. So n1 equal to 6. 6 by 8. 6 by 8 is nothing but 2 3 is 6, 2 4 is 8, 3 by 4. So n1 by n2 is your 3 by 4, a ratio between two integers. It is an rational numbers. So n1 by n2 is a ratio between two integers. That's why we have checked the multitone discrete time signals is a periodic. Individually, this cos x1 of n having fundamental period n1 equal to 6 and second periodic signal fundamental period n2 equal to 8. Then we have to check n1 by n2. If it is a rationals, we can say that the sum of discrete time signals are periodic. And here n1 by n2 equal to 3 by 4, ratio between two integers. That's why we confirm that this signal is periodic. Then find out the common period. How to calculate the common period? To find the common period, to find common period, then what we'll do? LCM of N1, N2, and 6 and 8 LCM of which equal to LCM of N1 is nothing but 6, N2 is your 8. LCM of 6 and 8 is how much? 6 and 8. That is your, this is nothing but 24. Is your 24. Okay. So in this example, the signal is periodic because N1 by N2 is an rational numbers. From this we can conclude that the signal is periodic, and to find the common period, the LCM of N1 and N2 is 24. And in these signals, the signal is periodic and the common period is 24. So thank you, students. The next class we will work out that is your even and odd signals, causal and non-causal signals. So different type of discrete time signal we will discuss, and we will do more and more number of problems that will help for your competitive examinations like engineering service examinations and GATE. Thank you.